Good morning class 9th, chapter number 4, structure of the atom. Student, in previous video we have discussed the charged particle in matter. There are the three types of the subatomic particles. What are these? Electron, proton and neutron. And electrons are the negatively charged and it is discovered by the J.J. Thomson. And the protons are the positively charged and it is discovered by the E. Goldstein in 1886. And the third subatomic particle is the neutrons. Neutrons have no charges and it is discovered by Chadwick, J. Chadwick in 1930. Yes student. Now in this video we will discuss the structure of the atom. The first structure of the atom is Thomson model of the atom. Student, an atom is electrically neutral. It contains positive charge due to the presence of the proton as well as the negative charge due to the presence of the electron. Positive charge due to the presence of the proton as well as the negative charge due to the presence of the electron. So student, Thomson assumed that atom is a uniform sphere. Uniform sphere. You can see this diagram. You can see this diagram. So student, according to the Thomson, the atom is a uniform sphere of the positive charge with electron embedded in it. You can see this diagram also. You can see this. So the atom may thus be visualized as a pudding, as a Christmas pudding. The Thomson model is similar to the Christmas pudding, and the pudding had the positive charge and the electron have the negative charge, like palms, or we can say that the dry fruits on the pudding. And you can this model, you can similar this the watermelon. In watermelon, the red edible part represent the proton and the seed represent the negative. So Thomson proposed that an atom consists of a positively charged sphere. According to the Thomson, the atom consists of a positively charged sphere. You can see this diagram. This is the positive charge. You can see this red part. You can see this. This is a positive. You can see this positive pudding. And the electron, you can see this. These are the electron embedded in it. And next, the negative and the positive charge. Electron charges and the positively charged P positive are equal in magnitude, in numerical value. So the atom is whole is electrically neutral. And this model is known as the raisin pudding model. Raisin pudding model. And this model explain the electrical neutrality of the atom, but fail to explain how these fundamental particles were arranged in the atom, especially the free positive and the negative charges so close to each other. So I think you have understand. So according to the Thomson model, yes, an atom consists of the positively charged sphere and the electrons are embedded in it, and the negative charge and the positive charge are equal in magnitude. So the atom as a whole is electrically neutral. So you can see this diagram also. Both are equal in magnitude. So if they have the equal in magnitude, so the atom is the electrically neutral. Okay. Now student, we will discuss the next model, Rutherford model of an atom. Student, Rutherford produced a narrow beam. He was interested that the how proton and electron, Rutherford interested in the structure of the atom, how proton and electrons are placed inside the atom was a matter, and the neutron had not been discovered then. So you can see this in 1911, scientist Rutherford of New Zealand gave a new picture of the structure of the atom by his alpha scattering experiment. This model is known as the alpha scattering experiment. So, Rutherford allowed a beam of fast moving alpha particle. What is the alpha particle? These are the doubly charged helium atom. Doubly charged the helium atom. Mass of the helium doubly charged 4U. You know this alpha particle is the doubly charged helium atom, and it contains 2 proton and 2 proton and 2 neutron. 2 proton and 2 neutron. This alpha particle does not contain any electron. And these alpha particle, the Rutherford allowed a beam of fast moving alpha particle having a positive charge. This helium, these are the, what are the alpha particle? Doubly charged helium atom having the positive charge to flow on a thin gold film. Thin. And he observed. So student, first listen carefully. Rutherford produced a narrow beam of alpha particle from a radioactive source, radium or polonium. Okay, so in his experiment, he saw that most of the alpha particle passed straight through the gold wave. You can see this. He observed that most of the alpha particles are undeflected. They pass straight through the gold foil. And some of the alpha particles were slightly deflected. You can see this diagram. A few alpha particles are slightly deflected. Okay. And some alpha particle, and out of 12,000 rays, one rays bounce off the nucleus. You can see there are the 3 observation. He observed 3 situation. Most of the alpha particle passed, you can see this diagram also, through the gold foil. Some of alpha particle slightly deflected by the small angle. You can see this diagram. And a very few, how much? Out of 12,000, 1 alpha particles appear to be rebound. He observed. Okay. Now, conclusion. What was the conclusion from the Rutherford alpha particles? Okay. The first situation was most of the alpha particles pass through straight through the gold foil. Why? Now you can see most of the space inside an atom is empty. You can see diagram. This is the atom, and the mostly alpha particles pass through straight. It means that most of the space inside an atom is empty. Okay. Why? Most of the alpha particles passed straight through the gold foil. Next, some alpha particle slightly deflected by the small angle. Why? Because an atom has a small nucleus, and this nucleus has the positive charge. An atom had a small nucleus having the positively charge. That's why some alpha particle having positive charge were slightly deflected by the small angles. If it has the negative charge, what will happen? It attracts the alpha particle, but alpha particle have the positive charge also, and it is slightly deflected. So it does, what does it mean? That the atom, this is the atom, had a small nucleus having the positively charged. It has the positively charge and it is deflected. And some rays, straight line. Okay. Now, third, a very few, 1 out of 12,000 alpha particles rebound. What does it mean? The size of the nucleus is very small as compared to the size of the atom. And also, student, the nucleus of the atom is dense or heavy. That's why one out of the 12,000 alpha particles rebound. So size of the nucleus is very small compared to the size of the atom, because a very alpha particle appear to be rebound. A very few means 1 out of 12,000. And most of the positively charged and mass of the atom is in the nucleus. And so the Rutherford model of an atom, what was the? So an atom has a positively charged nucleus in the center, and the most of the mass of atom is in the nucleus. So mostly mass tha na atom ka, the most of the mass of the atom is in nucleus. Next, the electron revolve around the nucleus. You can note down this. The electron revolve around the nucleus like this. The size of the nucleus is very small as compared to the size of the atom. This is the, you can see this diagram. The nucleus, the size of the nucleus is very small compared to the size of the atom. So I hope you understand, student. Okay. So according to the Rutherford model, an atom has a positively charged nucleus at its center, and most of the mass of an atom is in the nucleus, and the electron revolve around the nucleus in different orbits, and the size of the nucleus is very small as compared to the size of the atoms. And so what is the alpha particles? Alpha particles are the doubly charged helium atom. It does not contain electron. It contains 2 proton and 2 neutron, and the mass is 4u. So student, today we have discussed the Rutherford models of an atom and the Thomson model of an atom. In next lecture we will discuss the defect of the Rutherford model of the atom and the Bohr model of the atom, and how the electron settle in the different shell or orbits. So I hope you understand, students. Okay students, bye, take care.